ahead and get out our mountain math for today. Go ahead and put up your pencil, get out your red pen, and be ready to check with me. Number 1, we have the number 3 million. So when I go to round to the nearest 100,000, it stays 3 million, because this is basically 3 million and then 100,000. When we round to the nearest million, it stays 3 million. And then when we're going to round to the nearest tenth, we have to be specific. So we need to add our decimal point and a 0 after the decimal point. So it's 3 million and 0 tenths. Nearest hundredth is 3 million and 0 hundredths. And then the nearest thousandth is 3 million and 0 thousandths. Number 2, we have 0 and 71 hundredths, and then we have 0 and 7 tenths. So really what I should do is add a 0 after that 7 so that I'm comparing hundredths and hundredths. 71 hundredths is greater than 70 hundredths, so I'm going to circle that greater than sign. On number 3, we're multiplying. We have 347 times 112. So we need to multiply it straight through. Make sure that when you go through to multiply that first 1 that you have a placeholder or a 0. And when you multiply by the second 1, you have 2 placeholders or 2 zeros. And since we have no digits after the decimal point in our problem, we have no digits after the decimal point in our answer either. So our product is 38,864. On number 4, we're estimating to the nearest whole number, or the nearest dollar in this case. We have $24.50, which rounds to $25. $10.68 rounds to $11. And then $67.45 rounds down to $67. When I add up all of those whole numbers, I get $103. Make sure that you have your dollar sign there. On number 5, we're given 21e plus 4d. And it's a little bit scary looking at it and seeing 2 variables there, but all we have to do is evaluate by plugging in -3 for d and -7 for e. So I'm going to start by writing my problem, 21e plus 4d. On the next line, I have a new step. I'm plugging in -7 everywhere that I see an e, and I'm plugging in -3 everywhere that I see a d. On the next line, I'm going to start multiplying. So 21 times -7 is -147. And then 4 times -3 is -12. So let's think back to our integer rules. We know that we're adding, and the signs are the same. So we're going to add and keep the sign. 147 plus 12 is 159, and I'm keeping my negative sign. So now if you would go ahead and put away your mountain math, that goes in the front pocket of your folder, and turn to your Unit 2 test review. Remember that you have a test over Unit 2 tomorrow, so this review is going to help us to do really well on that test. Unit 2 test review. I'm going to work through each one of these with you. Make sure that on your paper you're working out the same problem and showing all of the steps. Your test tomorrow will be very similar to this review. So number 1 says, graph the solution for the inequality on the number line. Be careful about open and closed circles. So remember that a closed circle means that we are including that number. So we only use a closed circle if we have greater than or equal to or less than or equal to, and then an open circle is if we don't have an equal to, so greater than or less than. So we already know, just by looking at this problem, this is less than, so we're going to have an open circle on our number line. So I'm going to go ahead and circle open so that I remind myself when it gets time to graph my answer. So I have 7 minus 2x is less than 13. Now I'm used to seeing my x's at the beginning of the equation. If you want to rewrite this, you can. If I were going to rewrite this, I would need to make sure that I keep the minus sign with whatever's after it. So if I'm going to rewrite this, I'm going to write negative 2x. This is actually a positive 7, so I'm going to say plus 7 is less than 13. You don't have to rewrite it. You could leave it in the original form if you want to. It's totally up to your preference. So now I need to start working through the steps. Remember that we want to get rid of or undo the addition and subtraction first. So I'm going to undo adding 7 by subtracting 7 from what? From both sides. I am subtracting 7 from both sides. 7 minus 7 is 0, so I'm able to cross those out. And I get negative 2x is less than 6. So I just have one step left to go. Now, I don't really care what negative 2x equals. I want to know what 1x equals. So I'm going to divide by whatever's in front of x, which is negative 2. So over here, I'm going to divide by negative 2 also. And I finally have x by itself. Now remember that any time you divide by a negative, we're always going to flip the sign. So this is a little bit different than equations because our signs can go open to the left or open to the right. So I'm going to actually flip this sign because I divided by a negative 2. And then I'm looking here and I see that 6 divided by negative 2, well, my answer is going to be negative because the signs are different. 6 divided by 2 is 3. So I'm left with x is greater than negative 3. Now I haven't quite finished. I do have to graph that solution on the number line. And we know that we need an open circle because it does not include negative 3. It has to be greater than negative 3. So I'm going to put an open circle here at negative 3. And then it's everything that's greater than that. So it's all the way up to the end of my number line, and I need to include that arrow because it could keep going all the way up to infinity in the positive direction. Okay, let's look at number 2. A triangle has angles that measure 73.2 degrees and 12.7 degrees. So we're asked to write an equation that could be used to find x, the measure of the third angle in the triangle. Well, we already know what the total has to be for our triangle. All triangles add up to 180 degrees. So if I were going to be verbally saying this equation, I might say angle A plus angle B plus angle C equals or adds up to 180 degrees. So I'm going to go ahead and put my equal sign and my 180 degrees because that part's easy. And then I have two of my angles, 73.2 plus 12.7. And then I'm just going to use C for the third angle. So whatever that angle is, plus the other two angles, has to add up to 180 degrees. Now, whenever you're writing equations, you have to be kind of open and flexible because sometimes your answer choice may be written in a slightly different format. So you might see something like this, 180 degrees, and then start subtracting the two angles that we have, and then that would equal our third angle. These are both saying the same thing. We're either adding up all three angles to get 180 degrees, or we're taking our 180 degrees and taking away the two angles that we're given to solve for that last angle. Yeah, so this is algebra, and we're trying to get rid of everything that's not necessary. So in this case, if we were going to solve this, we would actually go through, we would subtract. Okay, so if we were looking at this top equation, I could actually subtract 12.7 from both sides. I could subtract 73.2 from both sides, and I would really be ending up with this equation right here. Okay, number 3 asks you to write a word problem that matches this equation. I'm going to give you an example, but I want you to write your own word problem. So here is my example. I might say something like this. Okay, well, I've got 15. This has nothing at all to do with my variable. It's just $15 or 15 pizzas or 15 students, whatever we want to talk about. And then this is 0.50, 50 hundredths, or 1/2 times x. So this does have to do with whatever variable we're talking about. So always ask yourself when you're writing a word problem or you're writing an equation, which one has to do with the variable? Not everything will have a variable stuck to it. So I'm going to write this word problem. Tom went to Six Flags. He paid $15 for a ticket. The park also charges 50 cents per ride. So the $15 for a ticket was whether he rode any rides or not. But it's also going to charge him 50 cents per ride. If Tom spent $37, how many rides did he ride? Okay, so we're solving for x. That'll tell us how many rides he rode. If we wanted to solve this, we would get rid of that 15 from both sides, and then we would be able to divide, but we're not actually trying to solve this. So I'd like for you to take just a minute, and you can work with your neighbor on this if you'd like, to write your own word problem. It may be similar to mine. Something that we could use with this equation. I need you back in 5, 4, 3, 2, 1. Let's look at number 4. Christina read 30 pages of a new book the first day that she bought it. After the first day, she read 11 pages a day. The book was 250 pages. Write an equation that could be used to determine how many days it took Christina to finish the book. So if I'm looking in my journal, which you should have your journal out, and I'm looking at my words to math page, then I know that the word was or is or will be means equals. So I'm looking here and I already know that I'm going to have equals 250. And then I'm going to start just working from my equal sign out. So I'm going to look at whatever comes next. So I'm looking here, it says after the first day, she read 11 pages a day. So I'm looking here and I see that it's 11 pages a day. That has to do with how many days. Okay, we're solving for the number of days. So I think that this is probably going to include a variable. This could also be written as 11 pages per day. So 11 pages per day would be 11, and let's use P for pages. Now I know that on the first day she read 30 pages, so I'm going to write 30 plus 11 pages per day, or 11p, equals 250. All right, let's look at number 5. Here we have Algebra Tiles, and it's showing us 1 minus 3x equals 7. So I have my positive 1, I have negative 3x's, and then on the other side of my equal sign, I have 7 positive 1s. So there's multiple ways to solve this. We're going to solve it first using the algebra tiles, and then we will do it with numbers as well. So remember that the first thing we want to get rid of is always our addition or subtraction. So this is really a plus 1. I could have rewritten this as negative 3x plus 1 equals 7. You see that that would have been the same thing. We have negative 3x plus 1. And I want to start canceling some things out. So the first thing I'm going to do is get rid of this positive 1. And if I get rid of this positive 1, I have to get rid of positive 1 from the other side. This is the same as subtracting 1 from both sides. So now if I'm looking at this, I see that I have negative 3x equals 6. So this is where I'm going to divide. I'm going to divide both sides by 3 here. So I have this, this, and this. I have 3 different pieces, and I'm going to divide this into 3 different pieces also. 1, 2, 3 pieces. So here we have negative 1x equals positive 2. And this negative 1x equals positive 2, and this negative 1x equals positive 2. Well, if negative x equals positive 2, then that means that positive x is going to equal negative 2. So I get positive x equals negative 2 as my solution. Let's go ahead and solve this using algebra as well. So I'm looking here, I have negative 3x plus 1 equals 7. I'm going to subtract 1 from both sides to undo adding 1. And I'm left with negative 3x equals 7. So that's the same thing that we had over here. but I still need to get x by itself. So whatever it is that I'm multiplying by x, -3, I have to also divide by -3 on both sides. And I'm sorry, this was 6, not 7. I hope somebody caught that. -3x equals 6. Divide both sides by -3. And we end up with x equals -2. Remember those integer rules. We want to make sure that we know a negative and a positive, the signs are different, then the answer is negative. So we got the same answer both ways. Okay, let's turn to number 6. Christopher and his brother have both been saving money to help pay for college. Christopher deposited $550 at a local bank 2 years ago, earning an annual simple interest rate of 7% paid upon withdrawal. So I'm going to go ahead and stop here for a second. I'm going to say Christopher deposited $550 2 years ago, 7%.
Wait, Miss Hendee, what does deposit mean?
Deposit means that I'm putting it into the bank.
So we're adding it then?
We are adding it to the bank, yes.
Okay, good reminder.
His brother, who does not have a name, okay, so brother deposited or put in the bank $700 2 years ago also, but he gets a simple interest rate of 5% paid upon withdrawal. So when he takes it out, after the 2 years, they're going to pay him 5% interest. So we have a 3-part question here. Part A says, how much interest did Christopher earn? Well, let's look. We remember our formula, interest equals principal times rate times time. And I look up here, I see my principal is $550. That's how much we started with. The rate is 7%, and the time is 2 years. So we're just going to go and start plugging this in. Interest equals 550 times the rate. Now 7% has to be changed to a decimal. So remember that if I'm going from a percent to a decimal, I have to go 2 places to the left with my decimal point. So 7% becomes 0.07 or 7/100. So I'm multiplying by 7/100, and then my time is 2 years.
Is the percentage always the rate?
Yes.
Okay.
The
So that's
percentage is
easy.
always your rate.
Okay.
So I'm going to start doing one step at a time. I'd like for you to go ahead and multiply 550 times 2. Since all I'm doing is multiplying, it's okay if I go ahead and multiply these two first and then only have to multiply by a decimal once. That's just a little shortcut. So go ahead and multiply 550 times 2. I'll do that quietly here. Okay, and I get 1100. So I have 1100 times 7/100. Please go ahead and multiply that as well. Now notice that I have 2 digits after the decimal in my problem, so I need to have 2 digits after my decimal in the answer. So my interest, or Christopher's interest really, is $77. Which means that when he takes this money out of the bank is going to give him his $550 plus an extra $77 for letting them use his money for 2 years. Not bad. So now let's do the same thing with Christopher's brother. So Christopher's brother is going to use the same use the same formula. Interest equals principal times rate times time. His principal, or beginning dollar amount, is $700. His rate is 5%, so 0.05. And his time is also 2 years. Again, I'm going to go ahead and do everything that doesn't have a decimal in it first. So 700 times 2, please multiply that on your paper. I get 1,400 times my rate, which is 0.05. Please go ahead and multiply that by yourself as well. And again, I have 2 digits after the decimal point in my problem, so I have 2 digits after the decimal point in my answer. So his brother earned $70 interest. So when he goes to the bank, they're going to give him his $700 plus an extra $70. So who earned more interest? Christopher earned $77 interest. His brother earned $70 interest. Please write a statement comparing the amount of interest Christopher earned to the amount of interest his brother earned after the 2 years. I might say something like, Christopher earned $7 more than his brother over 2 years. So I'd like for you to put that in your words and make a comment or a statement in a complete sentence. Okay, let's look at number 7. Solve the inequality. If you want to rewrite this, you can. The negative has to stay with your 3x. This is a positive 0.6. So I'm going to rewrite this as negative 3x plus 0 6/10 is greater than or equal to 3 9/10. So the first thing we want to do is get rid of whatever we are adding or subtracting. So I'm going to subtract 0 6/10 to get rid of this. And I'm left over with 3x is greater than or equal to, let's see, that's 3 and that's 3. So 3 3/10. I'm not quite finished. I still need to get x by itself. The opposite of multiplying by negative 3 is to divide by negative 3. On what? Both sides. So x, I'm dividing by a negative, so what does that do to my sign? We're going to flip the sign, keep that equal there. So it becomes less than or equal to instead of greater than or equal to. Now, I know that my answer is going to be negative because the signs are different and I'm dividing, so the answer is negative. Let's go ahead and calculate what 3.3 divided by 3 is. Put your decimal in your quotient and divide. And I get 1 1/10. So x is less than or equal to negative 1 1/10. They didn't ask us to graph it, so we're just going to leave it as an answer. Okay, number 8 is a review from Unit 1. A one-parent family with 2 children living in Crowley, Texas, has monthly expenses totaling $4,281. The mother works 40 hours per week. Assuming that a month has 4 weeks, we need to write an equation that could be used to determine W, the mother's minimum or lowest hourly wage that would be needed to meet this family's monthly expenses. So mom has a job. She works 40 hours a week for 4 weeks. How much does she have to make per hour so that they can continue to have this as their expenses? Well, if I have $4,281 that I'm trying to come up with, I'm going to divide that by 4 weeks. Okay, 4 weeks, to see how much I have to make each week. And then once I know how much I need to make each week, I'm going to divide by 40 hours to see how much I need to make each hour. And that's going to give me W, or how much mom needs to make per hour. All right, so number 9. We have pictures again. We have 2x plus 2, so we have 2x's plus 2 is greater than negative 2. We're going to solve this 2 different ways. So the first thing I need to do is get rid of this plus 2. Well, to get rid of the plus 2, I have to have 2 negatives there as well. If I'm going to add 2 negatives over here, which is the same as subtracting 2, then I need to subtract 2 from this side. So whenever I draw 2 negatives, that's the same as if I said minus 2. Same thing over here. Drawing 2 negatives is the same as saying minus 2. Now these get to cross out because that's a 0 pair. We learned about that when we were adding and subtracting integers. Oops, I'm sorry. I should not have crossed those out.
Way to go, Miss Hendee.
I know. Way to go. I have 4 negatives over here. Those don't cancel out. I was just seeing if you were paying attention. So now I'm left with 2x is greater than negative 4. So let's start dividing this up. Well, I'm going to divide it into 2 parts. So this side gets divided by 2. And this side gets divided by 2. So that x is greater than negative 2, and this x is greater than negative 2. Let's solve this algebraically to see if we get the same result. Hopefully we will. Otherwise, I made a mistake. Okay, so we have 2x plus 2 is greater than negative 2. Let's start by getting rid of our plus 2. We're going to subtract 2 from both sides. That's what we did here. So this is the same as adding on 2 negatives.
And if you guys do not have this written, you need to have every single bit of this written for you to get full credit.
Absolutely. Now on your test, you can solve it either way. So if this really isn't your favorite way to solve it, you do need to write it down. But on your test, you could solve it this way. So now I have 2x is greater than negative 4. I'm going to divide both sides by 2. 2 divided by 2 is 1, so I'm left with 1x is greater than negative 2. Now, I did not switch my sign here. Why on earth did I not switch my sign, but on number 7 I did switch my sign?
Because it looks like you're dividing by a positive right now, and when you divide by positives, you don't have to flip the sign.
Absolutely, that is correct. So because I'm dividing by positive 2, nothing happens to my sign. We keep it the same. And I have x is greater than negative 2, which is the same thing we got here. Okay, let's look at number 10. We are almost done. The school librarian has a budget of $875 to spend on books. She orders from a company that charges $9 per book, plus a $62 shipping fee for each order. The librarian uses the inequality below, where B represents the number of books, to determine if she has enough money to place an order for a specific number of books. So basically what this is telling us is Mr. Shorter has $875 to buy new books for the library. No matter how many books he orders, they're going to charge him $62. So he could order 1 book and pay $9 for that book plus $62 shipping, or he could order 100 books and pay $9 for each book, and it would still be $62 for shipping. So that's why the $62 has no variable. It doesn't change. No matter how many books Mr. Shorter orders, it's going to be $62 for shipping. But we're also going to be paying $9 per book, so 9 times the number of books that we order. And the reason this has to be less than or equal to $875 is because it's okay if Mr. Shorter doesn't spend the whole $875. If he only spends $800, then that extra $75 can just stay in his account. He just can't go over it. So he can spend up to $875. So the librarian already has a list of 50 books that she wants to order, and she planned to add more books to her final order. So Mr. Shorter's been making this list. He already has 50 books on his list that he knows he wants to buy, but he'd like to add some more books to that list before he goes ahead and submits that order. So will the librarian have enough money to add 45 more books to the final order? Okay, so we need to know, first of all, yes or no, and then we need to explain, which means that we are going to end up solving this equation, or this inequality. So how many books are we buying? Well, he wants to buy 50 books, plus he wants to add 45 more books. So 50 books and 45 books is 95 books. So let's plug these numbers into our inequality and see if it works. So if I have $9 times 95 books, plus I have to pay $62 for shipping, we need to see if that's less than or equal to $875. So notice that I'm plugging in a value here. This is the exact same thing that we do when we put our little checkbox and we plug our answer back into our equation to see if it works. That's all we're doing here. We already know how many books she wants to order. That's what we think X should equal, or what we think B should equal, but we're checking to see if it works. So now let's start doing one step at a time. Go ahead on your paper and find out what 95 times $9 would be. You need to have this worked out. Please don't just write down my answer. So for the books, if the librarian buys 95 books, just the books are going to cost $855. We still have to add on our $62 for shipping. So let's check this. Let's go ahead and say $855 plus $62 for shipping. Work this out on your paper. Well, if I'm going to order 95 books at $9 a piece plus $62 for shipping, that's going to be $917. Is that less than or equal to $875? Nope. So that does not work. So I'm going to do part of this with you. I'm going to say, no, the librarian does not have enough money to add 45 books. She could probably get those 50 books, but she can't add another 45. I need you, with your shoulder partner, to go ahead and fill in this part. You need to finish this, explaining the math, explaining these processes that we just went through. Tell us why she doesn't have enough money. Take about 30 seconds to finish that. Okay, I need you back in 5, 4, 3, 2, 1. Number 11. Jalen wants to buy a new pair of headphones. There are several stores that offer the headphones she wants, and each store offers a different rebate, summarized in the table below. So we have 5 different stores. They have different prices and different sales going on. So we want to know at which store would Jalen's total cost be the least after the rebate? Or in other words, which store is going to give Jalen the best deal? Her cost is the least. Which means that we need to actually go ahead and solve each one of these. So if I were you, I would add an extra column over here for my final cost. And Bob's Electronics is going to be the easiest. There's no rebate on that, so my final cost is going to be the same as the normal price, $125. So let's do each one of these. Starting with Best Buy, if the price is $140 and they will give me 10% off, then I need to figure out what 10% off is. Well, 10% of something, here's an easy, quick way to do this. 10% of a number, or 1/10 of a number, I can just move my decimal point one place to the left. That's the same as dividing by 10. Okay, that's the same as dividing by 10, or multiplying by 1/10. So these are all the same thing. So 10% off would be $14 off. $140 minus $14. Go ahead and work this out, please. She's going to pay $126 at Best Buy. Let's look at Walmart. Walmart is not a percent off, it's just a dollar amount off. So if Walmart charges $140 and is offering $10 off, I'm subtracting. And I know that I'm going to pay $130 at Walmart. So out of these three so far, Bob's Electronics with no rebate is still the best deal, but we need to keep going. Let's look at Target. Target charges $170, and they're willing to give me 20% off. Okay, now this is 20%, so I can't just use my decimal point moving trick. That's only for 10%, which means that I need to figure out what 20% of $170 is. If I change this to a decimal, that's the same as multiplying by 0.2. So $170 times 0.2 . One digit after my decimal point. So one digit after my decimal point. I'm going to add my money there. They're going to give me $34 off. Now that's not my sale price. I have to go ahead and subtract. So $170 minus $34. You're working this out on your paper. Means that after the sale, I'm going to pay $136 at Target. One more, we have Amazon.com. So Amazon usually charges $150, and they're going to give me $25 off. Since it's not a percent, I don't have to multiply and figure out how much that percent is. I just get to subtract. So that will cost $125 as well. So the lowest price after the rebate, looks like there's a tie between Amazon.com and Bob's Electronics. Okay, we have one more question today. We need to find the value of x in this equation, and then we're actually going to have to bubble it in over here. So we need to talk about how to bubble in our numbers as well. So let's start solving. 8x plus 6 2/10 equals negative 23 4/10. The first thing I want to do is get rid of plus 6.2. So I'm going to say minus 6.2 on both sides. Those cancel out. And now I have 8x equals, okay. Please, if you don't have your integer rules out, please open up your journal and look at that page. So this is basically saying negative 23 4/10 minus 6.2. I need to keep it, change it, change it. So negative 23.4 minus 6.2. The rule says to keep it, change subtraction to addition, and then change 6.2 to negative 6.2. Now I'm adding, and my signs are the same, negative, negative. So I'm going to add and keep the sign. So I know that my sign is going to be negative 23.4, 6.2. Bring that decimal down to your sum. And I get negative 29 and 6/10. We are not quite finished. We still need to divide both sides by 8. Cross those 8s out. I'm left with x. You still have your integers in front of you. When I'm dividing and the signs are different, my answer is negative. So you can go ahead and put your negative sign right there. And then let's find some space where we can divide 29.6 by 8. Please do this with me on your paper. So I have x equals negative 3 7/10. Now let's start talking about how we bubble this on our paper. On the last test, I noticed that there were a number of people that got the answer right, but didn't bubble it correctly. And so it actually got counted wrong by the system. And I want to make sure that you get credit for this. So the first thing I want you to always be in the habit of doing, and this is new, it hasn't always been this way, but you have to choose positive or negative. If it's positive, I really want you to go ahead and even bubble in the positive. That way you're always bubbling in something. So this is negative, so I'm going to bubble the negative sign. 3.7. Well, I can't just start right here next to the negative sign. I have to pay special attention to this decimal point right here. That's where everything needs to be focused. So here I have a decimal point. Right before the decimal point I have a 3. Let's bubble that 3. And right after the decimal point I have a 7. So I really don't need to have anything in these other columns. If you want to bubble in zeros, you can. Some people asked me last time, is it okay if I put negative 3.70? Absolutely, that's the same thing. But make sure that you always bubble your sign and all of the numbers in the right place. Now for my class, you have about 30 minutes, about 25 minutes, really, before you need to start cleaning up. So you can take this 25 minutes to do one of two things. You may either go back and review some of these problems with your neighbor or on your own to see what you need a little bit extra help with and practice. Or you may go and work on your mountain math that you missed, or something that you missed last week if you were absent or something like that. You may not be on your phone, you may not be on your laptop, and you should be working on something for this class. If your sub tells you that you're not allowed to work together, then you will be working on silence by yourself.